Welcome back, students. In this video, we're going to cover lesson 6-2, angle bisectors. Caveat to that, I'm gonna do example 4 on the back page on a separate video. Finding the incenter on the coordinate plane it's a little bit of a long problem. So, excuse me. So we're going to do it separate. All right. So 6-2 got two standards, GR1-1, 1.1, excuse me, and GR3.3. Get into the so theorem 6-4, angle bisector theorem. So if a point is on a bisector of an angle, so if it's on this guy, BF, then it's equidistant from the sides of the triangle. So if if BF intersects angle DBE, FD is perpendicular, FD is perpendicular to BD, and FE is perpendicular to BE, then DF is equal to FE, so these guys. So because it's equidistant, so they have the angle split, and basically what it means, so this guy and this guy are congruent. Excuse me. In the converse, so theorem 6.5 says if a point is in the interior of an angle, is equidistant from the sides of the angle, then it's on the angle, the bisector of the angle. So if FD is perpendicular to BD and FE is perpendicular to BE, DF is congruent, or DF equals FE, then BF bisects angle DBE. So I just said it backwards. That's where the whole P and Q statements we've spent so much time learning. All right, in theorem 6.6, so this is the incenter theorem. So the angle bisectors of a triangle intersect at a point called the incenter, and it's equidistant from the sides of the triangle. So in this guy, so P is the incenter. That means PD and PE and PF are all equal or congruent. So right here, so to the sides, where all of them are perpendicular, basically. So just like last video, we talked about the perpendicular bisectors met at the circumcenter. This is the incenter. Those were equidistant to the angle, or the vertices. This is equidistant to the sides. So just very similar to the last lesson. That's why today in class we went over both. We're going to go over both again tomorrow and work the practice some. But we didn't really get to example 4, and we're not going to cover that in this video, so I'm going to do it separate. Let me fix a little typo that I forgot again before printed for over here. All right, so example 1. Find QT. So if RS bisects angle QRS, then these guys are equidistant or congruent. Try not to mess up our equations. So for this, QT is going to be congruent to ST, because right here, so we just substitute out. QT is 4x plus 8 equals ST, 9x minus 7. All right, so you know me, I like to start with the smaller of the two variables. So we're going to subtract 4x from both sides. It's canceling over there. 8 comes down. 9x minus 4x is 5x. And then our negative 7 comes down. Let's see, 1 second. Excuse me. Okay, now plus 7, both sides. These cancel. 5x comes down. 8 plus 7 is 15. We're going to divide both sides by 5. And x is going to equal 3. If I could write better. All right, but they didn't ask for x. They asked for QT. So, excuse me. So QT equals 4x plus 8. 4 times x was 3, plus 8. So that's 12 plus 8. So QT equals 20. You can see that I didn't squish it up too bad. All right, for example 1, check you guys are going to find MS. So works exactly the same as this. If this is the bisector, these guys are congruent. Solve for X and then plug it in. I'm going to scooch down the page to example 3. All right, so example 3, P is the incenter of XYZ. Let me just grab my, so P is the incenter. All right, so if P is the incenter, that means that PL, PK, and PJ are all congruent because these are remember the incenter is equidistant from the sides. So we're going to write this up here. We're going to say that, what is it, PL is congruent to PK, is congruent to PJ. So, J. So here, here, and here. They want, for part A, they want us to find PK. So we have two sides over here. If we find this guy, we find this one because PJ and PK are congruent. We're going to use A squared plus B squared equals C squared, just like before. B, we're going to use the angles, but let's do the sides first. So notice here's our 90-degree angle. So this is our hypotenuse. So PK is our C squared. I'm sorry, PZ squared equals PJ squared plus JZ squared. JZ. Huh. Okay, so let's plug in what we know. Actually, and yeah, we're going to subtract here. I should have written it the other way. That's okay. As we write it down here, I'm going to... So A squared plus B squared equals C squared. C squared minus A squared also equals B squared. So we're going to... This is our C. This is our... A, this is our B. And you can do either one of those, but we're subtracting the hypotenuse because we have it. So we're going to say 7.3 squared, that's our C squared, minus 5.6 squared is going to equal our PJ squared. And PJ is congruent to PK, so that's how we're answering A. So we use our calculator. 7.3 squared. Hold on one second. Let me just do this real quick. Do not disturb. All right. I didn't bring my calculator, so we're going to use this. So 7.3 squared minus 5.6 squared equals. All right, so it's going to equal 21.93. So 21.93 is PJ squared. Now we want PJ. So we're going to take the square root. So we're going to bring this back over here. Hit the square root button, which is right here. And see, it's 4.682. We'll just say 4.68. So again, this says PJ, but PJ is congruent to PK, so it's the same thing. So PK equals 4.68. Let's make you feel better. Now let's go here. So part B. They want the measure of LPZ, so LZP, excuse me. So this one. So what do we know about these other angles? So remember, these are all angle bisectors. So if this side is 25.1, then this side is 25.1. And if this side is 24.6, then this side is 24.6. So remember, without all this stuff, we have a big triangle, so we can find out what both of these are and then divide it in half because it's going to be the two halves. So 25, so angle Y, 25 25.1 plus 25.1 is 50.2. For x, 24.6 plus 24.6 is 49.2. So to get angle Z, it'll be 180 minus 50.2, which is this guy, minus 49.2, which is that guy. So subtract, excuse me, subtract those both out. I gotta go back to my notes. Let's see. All right, so we subtract all those and we get 80.6. So angle Z is 80.6. Remember, these are 2 halves, so divide it by 2. And the measure of angle LZP, so which is half of 80.6, is 40.3 degrees. So we just deconstructed this guy and made it a big triangle so we could find these 2 angles and split it in half. All right, flip it over. So you guys have this example 3 check at the top. You're going to do the same thing I did. So define JF. And I'm going to help you out just a little. So angle bisectors means JF, JE, and JD are all congruent. So you have 2 sides here. You just need the third. This is across from the 90-degree angle, so that's your hypotenuse. So it's this minus this is going to give you this, which is the same as the other 2. So I've explained it all. Hopefully you guys can get that. All right, and now angle JAC. So one side of this. Remember, deconstruct. This is a big triangle. This is half. The other half's the same. This, do that. Subtract it from 180. It'll give you this whole angle. Divide it in half and you'll get both sides. We're going to skip this. I'm going to do this in a separate video. For example 4. It's a pretty big problem and I want to do it separately because we're going to need a little extra room. So at the bottom here, our practice, it's 1 through 13. Wait on the example 4 video to do numbers 12 and 13. Those 2 go by this, so just hold off for now. Just do 1 through 11. Summary: the the angle bisectors of a triangle intersect at a point called the incenter that's equidistant from the sides of the triangle. So, if you have any questions aside from example 4, like I said, separate video coming, please let me know. Otherwise, have a good night.